What if I told you that Earth is already doomed and there's absolutely nothing humanity can do to stop it? Not by technology, not by colonizing Mars, not by building megastructures the size of planets. The Sun, the very star that makes life possible, is also Earth's executioner, and its plan is already in motion. Science fiction tells us we'll outsmart nature, that we'll engineer our way out of extinction. But real astrophysics tells a colder story. Stars don't negotiate, and physics doesn't care about intelligence. This isn't about if the Sun will destroy Earth. It's about why every proposed solution quietly collapses under real science. So tonight, we're not asking how to save the planet. We're asking a more uncomfortable question. Why is stopping the Sun fundamentally impossible? Before we go any further, it's important to be clear about what this video is and what it is not. This isn't anti-science, and it's not science fiction dressed up as fear. Everything you're about to hear comes from mainstream astrophysics, the same stellar evolution models used by NASA, the European Space Agency, and observatories around the world. These are not fringe ideas. They're based on nuclear fusion equations, solar luminosity measurements, and simulations that have successfully predicted the life cycles of stars across the universe. The Sun is not a mystery object. We know its mass. We know its age. We know its fuel supply. And most importantly, we know how stars like it live and how they die. Where skepticism enters isn't about what will happen. Scientists overwhelmingly agree on the Sun's long-term fate. The debate begins when we ask a more human question. Can intelligence override stellar physics? That's where optimism often replaces evidence. You'll hear ideas about moving Earth, building Dyson spheres, or transforming humanity into a multi-star civilization. These concepts sound scientific, and sometimes they start that way, but they quickly drift into speculation once energy limits, material constraints, error margins, and long-term stability are taken seriously. This channel exists in that uncomfortable space between knowledge and hope. We trust the math. We trust the observations. But we're skeptical of promises that quietly ignore physical limits. So as we move forward, the goal isn't to debunk science. It's to strip away wishful thinking and confront what the universe actually allows. Because understanding our limits may be the most honest form of intelligence we have. Now we reach the heart of the issue, the part that most optimistic visions of the future quietly avoid. When people talk about saving Earth from the Sun, they usually imagine a single catastrophic moment far in the future. A red giant explosion, a final blaze of destruction. But that's not how extinction actually unfolds. The real problem isn't one event. It's a process already underway, governed by physics that cannot be paused, negotiated with, or engineered around. Let's break this down carefully. The Sun feels constant, reliable, eternal. But in astrophysical terms, it is anything but stable. Right now, the Sun is about 4.6 billion years old, roughly halfway through its main sequence life. And as it ages, one critical change is already happening. It is getting brighter. This isn't speculation. Stellar evolution models, confirmed by observing millions of other stars, show that the Sun's luminosity increases by about 10% every billion years. That may not sound like much, but Earth's climate exists on a razor-thin margin. A few percent increase in solar energy is enough to disrupt the carbon cycle, accelerate water evaporation, trigger irreversible greenhouse feedback loops. Long before the Sun becomes a red giant, Earth enters what scientists call a runaway greenhouse state. Oceans evaporate. Water vapor, itself a powerful greenhouse gas, traps even more heat. Surface temperatures spiral upward. Life doesn't wait for the Sun's final act. It ends quietly, early, and permanently. And this is the first uncomfortable truth. By the time humans could even attempt large-scale planetary engineering, Earth's habitability window is already closing. Billions of years sounds reassuring, until you realize complex life has only existed for a fraction of that time and civilization for a microscopic sliver. The Sun doesn't need to explode to destroy us. It just needs to keep shining. So what's the most common counterargument? Why don't we just move the Earth farther away? On paper, it sounds elegant. In reality, it's one of the most impractical ideas ever proposed. To change Earth's orbit, you would need to add or remove enormous amounts of orbital energy. Do so with extreme precision. Maintain stability for millions of years. Even minor orbital errors would be catastrophic. Too little energy, nothing changes. Too much, Earth is flung into a colder, unstable orbit. or ejected from the solar system entirely. Some proposals suggest using repeated gravitational assists from asteroids or planets. But this introduces chaos into an already delicate system. Planetary orbits are interconnected. Alter one and you risk destabilizing the entire solar system. And then there's the energy problem. The energy required to shift Earth's orbit outward even slightly is orders of magnitude greater than all the energy humanity could produce, even with perfect efficiency over millions of years. This isn't a technological challenge. It's a conservation of energy wall. Physics doesn't care how clever we are. It only cares how much energy we can actually move. At this point, the discussion often escalates to megastructures, Dyson spheres, Dyson swarms, planetary sunshades. The idea is simple: control the sun's output and you control Earth's fate. But once again, the details destroy the dream. A true Dyson sphere would require material equivalent to entire planets, structures that must remain stable for millions of years, continuous maintenance against collisions, radiation, and orbital decay. Even a partial swarm introduces new problems: waste heat that must go somewhere, gravitational instability, cascading failures, one collision triggering many, and sunshades. They help briefly, at best. They don't stop the sun from aging. They don't stop fusion in the core. They don't stop luminosity from increasing. They only delay the inevitable while requiring constant intervention across geological timescales. This raises a critical question rarely asked. What civilization, no matter how advanced, can guarantee uninterrupted maintenance for millions of years? History shows civilizations struggle to maintain infrastructure for centuries. The universe doesn't grade on effort. It grades on endurance. So what if we abandon Earth entirely? Mars, Europa, exoplanets around distant stars. This idea sounds bold, until you zoom out. Most stars follow the same basic life cycle as the sun. They brighten, they expand, they destabilize their systems. Red dwarfs? They bombard planets with radiation and often tidally lock them. Larger stars? They burn faster and die more violently. Finding a planet isn't the same as finding a stable, long-term cradle for civilization. And even if humanity spreads across multiple worlds, the core issue remains. Biology is fragile, and cosmic environments are hostile. Survival on another planet doesn't guarantee cultural continuity, technological resilience, long-term independence from stellar behavior. Becoming a multi-planet species sounds reassuring, but it doesn't free us from astrophysics. It just spreads the risk. This is the final immovable wall. The sun is powered by nuclear fusion, hydrogen turning into helium, energy released according to equations that have never been violated. As hydrogen runs out, the core contracts, temperatures rise, fusion accelerates. To stop the sun from destroying Earth, you would need to alter fusion rates inside a star remove or add mass with perfect precision, maintain stability without triggering collapse or explosion. Any meaningful interference would likely destabilize the sun, alter planetary orbits, or destroy the solar system outright. This isn't engineering anymore. It's cosmic scale manipulation bordering on the absurd. Intelligence does not equal control, and the universe offers no appeals process. Every proposed solution, when followed to its logical end, fails for the same reason. They collide with unchangeable physical limits, not political limits, not economic limits, not imagination limits, but the limits written into the structure of reality itself. Once you accept that the sun's destruction of Earth is unavoidable, a more disturbing layer of questions begins to surface. Not technical questions, existential ones. If intelligence cannot overcome stellar evolution, then what does progress actually mean? We often assume that technology is a one-way path upward, that every problem eventually yields to innovation. But the universe doesn't seem to reward intelligence with permanence. It allows complexity to emerge and then quietly places a time limit on it. This raises an uncomfortable possibility. Maybe extinction isn't a failure, maybe it's the default outcome. Civilizations may not die because they make mistakes, but because they are born inside systems that guarantee their end. And if that's true, then the sun isn't unique. It may be part of a broader cosmic pattern. This brings us to the idea known as the Great Filter, the hypothesis that something prevents most intelligent life from surviving long enough to become truly cosmic. We often imagine that filter lies behind us: nuclear war, pandemics, self-destruction. But what if part of the filter lies ahead? What if stellar evolution itself is the ultimate barrier? Not something to be solved, but something every civilization eventually collides with. That would explain something else that has haunted astronomers for decades. The universe is vast, ancient, filled with stars far older than our sun, and yet it is silent. No visible megastructures, no star-scale engineering, no unmistakable signatures of civilizations that learned how to cheat time. If mastering stars were possible, we should see evidence everywhere, but we don't. Which raises another unsettling question. Do advanced civilizations simply run out of time before they run out of ideas? Even spreading across planets doesn't guarantee survival. Complexity introduces fragility. Every added system is another point of failure. The longer a civilization exists, the more opportunities it has to collapse, socially, biologically, or technologically. So maybe the question isn't, how do we stop the sun? Maybe the real question is, why do we assume we're supposed to? The universe never promised permanence. It only allowed moments, moments of awareness, moments of curiosity, moments where matter briefly learned how to ask questions about itself. And that leads to the most unsettling thought of all. What if intelligence is not meant to win, but simply to understand? So where does this leave us? If the sun cannot be stopped, if Earth's destruction is written into stellar physics, and if no amount of intelligence can rewrite nuclear fusion, then the story of humanity isn't one of ultimate victory over nature. It's a story of temporary understanding. For centuries, progress has been framed as conquest, conquering land, disease, distance, even death itself. But the universe doesn't seem impressed by ambition. It operates on scales where intelligence is a brief, flickering phenomenon. And maybe that's the point. The goal of a civilization may not be to survive forever, but to see clearly while it exists, to map reality honestly, to understand the rules instead of fantasizing about breaking them, to recognize limits not as failures but as truths. Stopping the sun was never a realistic objective, but understanding it was. And that understanding matters, because it strips away comforting illusions and replaces them with something rarer, clarity. If extinction is inevitable, then meaning doesn't come from permanence. It comes from what we do with the time we're given, from the questions we ask, from the knowledge we preserve, from the honesty with which we face the universe. The sun will continue to shine, it will continue to change, and one day it will erase the conditions that made us possible. But before that happens, there is this moment, a moment where the universe, through us, became aware of its own limits. And perhaps that not survival is the quiet victory no star can take away.